Hi, welcome to my video about DISC-1 and its interrelationships with a bunch of neuropsychiatric disorders as well as diabetes. My name is William Jang. I'm a Master of Library Science. I used to be the Chief Librarian at Columbia University Psychiatry, New York State Psychiatric Institute, arguably one of the finest psychiatric institutes in the world. So this is my author page. Check it out if you'd like. It's at Amazon.com. I've written a book about my life called The Schizophrenic Will, A Story of Madness, A Story of Hope, as well as a book that does quite well called Guide to Natural Mental Health. And everything on this page is one of my books. Everything from a guide to fun in New York to just some interesting stuff. So I just wanted to show you that real quick. All right, so to the topic, DISC-1. Otherwise known as Disrupted in Schizophrenia 1, so named because it was first, its mechanism of action of this gene was elucidated by, it was implicated in schizophrenia. So it deals with cell proliferation, differentiation, migration, neuronal axon and dendrite outgrowth, mitochondrial transport, fission and fusion, and cell-to-cell adhesion. So it turns out that disrupted in schizophrenia 1 is not only a protein that is implicated in schizophrenia, but also clinical depression, bipolar disorder, and other psychiatric conditions. So that's very interesting in and of itself. And so the variations of DISC-1 gene have been related to structure and function of the hippocampus in particular. Also probably other areas of the brain. However, here we see the hippocampus deep in the brain in the limbic system, or it's one of the oldest portions of the brain. We know that the hippocampus is important. It's a small organ. Let me just read this for you. Within the brain, and the temporal lobe, and forms an important part of the limbic system, the region that regulates emotions. Therefore, the link with psychiatric disorders with DISC-1. So the hippocampus is associated mainly with memory also, in particular long-term memory. And the organ also plays an important role in spatial navigation. So not only does the hippocampus regulate emotion, but it also regulates so memory and also spatial navigation. So you couldn't be an architect with a dysfunctional hippocampus, and it would probably be very difficult to remember things if your hippocampus were dysfunctional. And of course, the emotional issue is key. So the reason for this video today not only is to talk about DISC-1, which is something that really makes us quite human. And because without memory, we would not learn anything, right? Without being able to regulate our emotions, we wouldn't be able to stay out of jail. So the scientists discovered a molecular link between DISC-1 and type 2 diabetes. So it turns out, let me see, where are we? So the researchers found that DISC-1 works by controlling the ability of a certain protein already known to be critical for beta cell function and survival in the pancreas. So when this was inhibited, it improved beta cell survival and restored normal glucose tolerance in mice with disrupted DISC-1 in the pancreas. So alterations in the DISC-1 gene were originally associated with the increased risk of schizophrenia, but yeah, so also bipolar and major depression. So basically, one disorder in DISC-1 can actually cause any number of these disorders, from diabetes to schizophrenia to bipolar to depression. And so nothing in a biological system seems to be completely separate from the other systems in the biological system. They're all interconnected. So yeah, that's really what I wanted to show you about DISC-1, and they're hopefully going to be able to do therapies using the DISC-1 gene, and hopefully they'll be able to prevent things like diabetes and also help treat neuropsychiatric conditions such as schizophrenia. Thank you for watching.